Hello and welcome to Total Destruction Volume 3, Particles. Particles are an essential and sometimes overlooked part of creating visual effects. It doesn't matter if you're creating destruction effects, abstract effects, or simply motion graphics, chances are you will be using particles in some extent. In this tutorial, we will start with the basics of particle emission and quickly move into forces, collisions, instancing, rendering, and we will even take a look into grains. We will create very practical exercises like fire, secondary destruction, debris, and even some mortar explosions. Along the way, I will teach many practical tips and some very handy tricks that I use in almost all my particle setups. We have a lot of new things to learn, so let's get started. In our first exercise, we will be creating this fire effect. And granted, it's not a photoreal effect. It can be a very fast and cheap way to simulate fire. It can be the base for emitting more realistic fluids later on. So let's take a look how this effect was created. The first thing, and probably the most important thing that we need to do, is to create our emission geometry. So let's start by creating a geometry node. Let's call it fire and dive inside the node. In this case, I will create a circle. I'll just make sure it lies on the ZX plane. And I will change the size to 0.5 in radius and 0.5 in uniform scale. Now let's make sure it's a polygon, not a primitive. And we can also increase the divisions to say 40. Now this itself would be enough to create particles or to generate particles. So let's try creating a pop network. So press tab and type pop network. Connect the circle into the first input of the pop net. And that's it, we're ready to generate particles. Try pressing play and you will see that a bunch of particles are being created. Nothing really exciting now, but we have something working. So let me stop the animation and click here on the real-time toggle. This will be important so you can see the velocities and the motion of the particles in real time. So before we dive into the DOP network, let me change the color of the node. I usually color orange my DOP networks. So let's also change the name to Pop Fire. And let's dive into the node. So whenever you create a pop network, there are three basic things that are being created for us. The actual particle solver, the particle object, and a particle source. The particle source is extremely important. It not only determines which part of the geometry will create the particles, but it creates most of the particles' attributes themselves. So before I continue, let me make a quick change here. I will change this property to set initial velocity. And I will go back to my sourcing parameters. So by default, the emission type is set to scatter onto surfaces. This means that every face of the geometry will be used to generate particles. So if we press play, now we will see these particles rising due to the velocity I added here. And notice we have particles generating through all the entire face. I will leave the emission type on scatter onto surfaces for now. And for a minute, I will go into the birth attributes. I will go back to the scatter emission types in a moment. So here on the birth tab, you have a few very important attributes of the particles. Probably one of the most important will be the life expectancy. So this is a time in seconds. For example, if I bring back the life expectancy to 1, you should notice that the particles will live for 24 frames and then they will start dying out. So let's try to go frame by frame. So after frame 24, you'll notice that the particles will start to die. Now, there's a life variance, which is also very important. I will bring the life variance to 0.5. And this means that now the particles may live between 36 and 12 frames. So 0.5 seconds after and 0.5 seconds before. And this will make a much more organic feel, much more natural. Not all the particles will die at the exact same time. So usually I leave a little bit of variance to the life expectancy. Another very important attribute is the constant birth rate. And if you notice here, we have two types of activation: impulse activation and constant activation. So they are similar, but let me show you real quick the differences. If you notice here under impulse count, we have 0 particles. It is activated. For now, let me turn that off. So 0 would be off, 1 would be on. Same for the constant activation. I will turn activation to 0 or off. So now if we press play, nothing will happen because neither impulse nor constant activation are on. So let's start with constant activation. Now, if we press play, you will notice that after 1 second, we should have 5,000 particles living in the scene. So let's try to see. Let's go to frame 44. Now, this may not be exact, but we should be around the 5,000 count. So let me go into the information here. And you can see we have 4,300 and so particles. Maybe if we decrease the life variance to 0, we'll be more close to the 5,000. So yeah, here we go, exactly 5,000 particles in 1 second. So remember, they're all dying in frame 24. Now the impulse count is a bit different. Here with this constant activation, you don't know exactly how many particles are being emitted per frame. We just know that after 24 frames or after 1 second, we'll have more or less 5,000 particles. The impulse activation works a bit differently. Let me turn off constant and let me turn on impulse. Let's increase impulse count to 1. So now every single substep, we will have 1 particle emitted. And by substeps, I mean the number of calculations that are being done by the pop solver per frame. So if you go up to the DOP context and select your pop network, you will see here your substeps. By default, there will be only 1 substep. This means that the network will be evaluated once per frame. If you increase this substep, the entire network will be evaluated 2 times per frame. And if we now go back to frame 0 and advance frame by frame, you will notice now that 2 particles are being created per frame. If we increase this to 10, for example, we know that 10 particles will be created each frame. So in some cases, the impulse activation will be very useful. In some other cases, you might use constant activation. It takes a little bit of practice to know when to use which, but in general, I will usually start with a constant activation. And if that's not working for me, I can go into impulse. Impulse activation can be useful, for example, to create explosions where you just need particles generated in a single frame. Or it is also useful to create trails where you know that each substep you want new particles to be generated. So finally, back to the sourcing. Right now I will change the emission type to points, which I usually prefer. And this will generate particles only from the points on the geometry. And let me go back to the sub context. And after my circle, I will add a scatter node. This will let me create a number of particles that I can control. So let me increase the total count to 10,000. You can also turn off relaxed iterations. So first of all, with relaxed iterations, you will have a very regular distribution of points. But also, if you try to increase this number too much, the relaxed iterations will make it a bit slow to calculate. So if you're considering using a lot of particles, you may want to turn this off. And also, if you want a more uneven distribution of points, it's a good idea to turn off relaxed iterations. So let me go back to 10,000 and dive back into the DOP network. So now the particles will be randomly generated from different points of this point cloud. Now, if we go back to the birth attributes, you will notice that still we can choose impulse and constant. But if we select all points and go back to the birth, only impulse activation will be available. So with this option, we know that one particle will be emitted for every single scattered point. So just be aware that the main difference between these two types of emissions, points and all points, will also impact in your activation options. So for now, I will stick to constant activation and points emission type.